All right, so we're going to talk about messaging and modern observability. So hopefully you are here to see that. Who are we? So I am Ian Cooper. I know it's hard to tell us apart with the beards. So I'm a messaging guy. I've been doing messaging for years, been building event-driven architectures for probably 20 years at various companies. For those of you .NET fans, I work on a open source .NET messaging framework called Brighter. We are non-commercial, in case that's interesting recently. And this is Martin. Martin, you are?
So my name is Martin Thwaites. I go by martin.net on the socials. And I am an observability guy. I've been in the monitoring and now observability space for, let's just say, a number of years. I've been doing this kind of stuff. I work for a company called Honeycomb. You may have heard of us. We're an observability backend. We'll show a little bit of Honeycomb today, but that's not really what we're here to talk about. We're really here to talk about structure and things like that. We're also both Microsoft MVPs, so a lot of the all the examples that we're going to run through today are all in .NET. It's probably worth framing why the two of us are here, because it seems like an unlikely combo. We're not twins. That isn't the reason we're here. But it's two sides of what is going to be quite interesting for a lot of people, which is, how do we understand event-driven systems? So Ian came to me, it was probably about a year ago now, and was like, Mike, can you give me some pointers on observability, because I'd like to add that to one of my talks? And I'm like, you do realize it's a fairly big subject? So maybe we do a talk together as somebody who knows everything there is to know about messaging and somebody who knows a bit about observability. So that's really where this talk came from, which was, we want to talk about how observability is different in event-driven systems, but also how does that differ in modern observability worlds. You might call it observability 2.0 or 3.0 or 10.0, who knows. But essentially, what does modern observability look like?
And there are two of us. The stage is suspended above, basically, the seating area below. And neither of us are small lads, so we'll see how well Norwegian engineering holds up.
And we also walk quite a lot.
Yeah.
So if you see us like swaying that way,
this could be a much more exciting talk than you were prepared for. All right, what's our agenda? So I'm going to talk about a little example that we've created, most of which you can really view the detail on yourself in your own time. I can see the one behind you, mine. We're going to look then at how, in terms of a design time, thinking about messaging, how we understand what our system is doing. And then we'll talk a little bit in the section on blindness about how that viewpoint is limited when it comes to runtime. And then we'll hand over to Martin, and you will...
And I will show you the light.
Okay.
I will bring you from the blindness into being able to see everything.
Previously, we've not discussed you as a miracle worker, but all right. So what's the example? So you can find the example on my GitHub. There's a load of .NET code there that will run through it. What we're trying to do is a very simple example. So we're trying to show you a pizza shop. Everyone in messaging seems to be using pizza shops at the minute.
Narrator, it wasn't simple.
Yeah, true. Where effectively what we say is, you as a customer, we're not going to actually have an app. We're just going to go to an HTTP API. Are going to place an order for a pizza. Our pizza shop is going to cook the pizza, and a courier is going to deliver the pizza. And obviously, there are some message interactions. So we're going to basically send a message to order the pizza. In theory, you could get a message which says, hey, we can't take your order because we've run out of ingredients. We don't have any pineapple or anchovies left. And then essentially, you're going to cook the pizza, and then you're going to need to find a courier to pick up the pizza. You're going to tell the courier the pizza is ready. The courier is going to come to your house, and you're going to want to see some notifications that the courier is on their way. Now, as Martin was alluding, this is, in theory, quite a simple example. The idea was, I said to Martin, I can build you one of these pretty fast, and we can get it running. And our plan was that I would build this code, we better show it to you, and then Martin would come along and say, now we can make it observable. We had a slight problem.
So Ian came to me about 3 weeks before the talk and said, Martin, it doesn't work. The thing I've built, it just doesn't work, and I don't know why. I was like, well, I have a fix for that. So in order to write the talk about observability, we actually had to instrument the code first to work out why it wasn't working, fix the code, and then remove the observability so that we could then show you how to add the observability.
We sort of proved our own thesis, which is it's impossible to really understand event-driven systems without decent observability. We'll talk a little bit more about why, but it was a journey. Let's just put it that way.
Journey, yes.
All right. So when we think about any kind of distributed system, what we really want to think about is what kind of lenses do we have to view and understand that system. So there are a few ways at design time we can think about an event-driven architecture. You could use sequence diagrams. You could use UML collaboration diagrams. If you know what they are, they're just an alternative way of seeing a sequence diagram. One I quite like, though it's a bit more heavyweight, is BPMN. We're not going to try and teach you BPMN, but we're just going to give you enough to give you a feel of how you might use that as a design tool. So this is a classic kind of BPMN diagram. So typically, anything in BPMN starts with an event. So event is just a signal here. It isn't necessarily a particular type of message. And it will end with some kind of event. In this case, you can see that because we've got that black icon, there's actually a message being sent at the end here. And in between, effectively, we do stuff, right? In between, that's effectively our workflow. And our workflow consists, essentially, of a series of things we call tasks. You can see they may have little icons. This one's got an icon for being basically a kind of a user-defined activity. And the tasks are organized in a sequence, which is indicated by that line between them. So it's a way, effectively, of seeing something happening. So this is what we call basically an orchestration. It is essentially done by a pool, and a pool just really means essentially some running process, right? And we have a notion in BPMN of a token, and that really just means state. So effectively, it's a process where we maintain the state of a workflow. So in other words, we know what steps we've reached and how far we've got. All right? And that is technically what an orchestration is. Some places you'll hear people talk about, oh, orchestration is commands and choreography is events. That's not true. Right? So an orchestration just means somebody is in charge and tracking the state of individual flows through it. So here you can see what we're talking about. On the left-hand side, some user icons. This is the user interacting with our API. Selecting their pizza. We're not showing any kind of API call here. We're just showing the user in that box doing something. The user then effectively checks out. You can see we've got some messaging icons. That's indicating basically that we're waiting, and we're waiting basically for a signal, which is either going to be, hey, the order gets rejected, a message gets sent to us. It may well be a timeout saying, oh, you know, why isn't my pizza here? And eventually, hopefully, we get a pizza delivered to us, and that kind of ends the flow. Of course, we aren't making our own pizza. So there's another pool, and I can think about another microservice, and that one's going to run effectively a whole series of steps to enable us to cook a pizza. You can see here we've got some little message icons. So what we're doing here is we're actually sending some messages. There's no kind of dotted line. There's one for accepting or rejecting the order. That's what we've been sent by the customer. So that's that first message. And then we say, I'm going to send a message back to you to accept or reject it. And then effectively we cook the pizza. And we also signal to a courier to say, hey, first of all, are you available? And second, basically, it's ready for you to pick up.
There is a test at the end, so do make sure you memorize.
Yeah. And finally, we get into one where essentially you've got the courier. The courier effectively is saying, is going to receive a message saying, can you accept this order? They can reject the order. They then wait basically for a signal for us to say, oh, okay, the pizza is ready to be cooked. And then they will send signals to the customer as they're journeying, messages again saying the courier is on its way and being taken. Now, we can view all that as a lovely collaboration diagram.
Is this a bad time to say that on the plane I added a new service?
Yes.
I mean, this is the problem, isn't it? That we've got all of this. This is what it looks like. Great. Well, this is what you designed it.
Yeah.
This is not what production looks like.
And that's one slight problem we're going to hit early on, is that this is great as a design time diagram, but it's not going to tell us about production. Now, if you want to know what a choreography is, so a choreography is essentially how we map all those little message flows that we saw earlier in here. How do we map them out in a way that's more visible? And that's called a choreography. So I don't want to go into the depths of how you do choreography, but essentially each one of those boxes is an interaction, and the gray line indicates the receiver. So that's what a choreography looks like. It's that interplay of messages between the various systems that we have. So you do messaging, you always have choreography, right? this is our choreography, the choreography for a pizza shop. Now, even in terms of that fairly simple flow, there's quite a complex set of interactions that we're seeing here. So complexity is building up. We're not doing anything that hard, but complexity is building up.
But yes, this is the idea that we've got tons of ways of representing how we design them, how we build them. All of that stuff exists in those diagrams, but as proved before, like I was bored on the plane, and I added a new service for auditing, which is nowhere on any of those diagrams, which leads into this idea that, well, you don't know exactly what actually was developed. You don't know how any of this is interacting. You know how you designed it. You know how you thought it should work. You know how you meant for it to work. But is that actually what it's doing?
Yeah. So this idea effectively is that they're design time views, and they give us no insight into the runtime behavior of our system. It tells us what was supposed to happen, not what is actually happening. And so we can't tell things, for example, like if a message doesn't reach us from the courier, basically giving us an order status update, which is what happened when we were trying to test it, what happened? All I know is I'm not receiving a message. I don't really know what that means. What happens effectively if it seems to be really slow? Why is that happening? What happens if the restaurant complains they're not getting any pizza delivery messages? Where does that come from? And I get no business insights. I can't figure out, is it taking my couriers a really long time to get there? Should I adjust my ETAs? Are my cooking times all off? Should I adjust my pizza cooking times? I've got no insights. I can't see what's happening. We're stuck in this slight position that our viewpoint for any given team is usually one of those pools. That's usually a microservice, and all they can see is what's happening inside the event horizon of their service. They want to travel outside that service and see the flow of messages. They can't. There is nothing that lets them view the choreography that is happening in between the various services. There is effectively no stack trace in a distributed system. I can't, if there is a problem in one of my services, and my services basically goes wrong, I can't see the stack trace to where the messages came from which caused that failure. Or as a business problem, if all my orders are being rejected, I can't see how that happened. I have no visibility of what's going on. And so it's very difficult for me to debug a distributed system. It's very difficult for me to debug that choreography. The orchestration, yeah, I'm okay. I can probably stick a breakpoint in that and see how it goes. It's a bit hard to do at runtime on my actual server, but I could probably take something off the server that lets me do that. But the choreography is almost impossible. I have no viewpoint on that. I just know something left my system and something didn't arrive or arrived badly in another system. And so we could try just debugging everything. So Martin and I decided, because, you know, we're Microsoft friends, we wanted to run Aspire so that we could run everything, and that introduced a whole new set of difficulties.
Oh, yes, yes. Now we had 14,000 problems instead of 2.
Yes, but you could try that. But a lot of the code is going to be foreign code to you. You don't understand it, you don't know where it came from, and you're trying to figure your way out through somebody else's code base and trying to get it running just to try and trace those jumps that you're seeing in terms of messaging. Right. So the problem is that we need to be able to have some way to light up some kind of diagram at runtime that is, I feel like, a runtime version of that choreography diagram. That it's going to say, at runtime, what are those interactions that are happening? How can I determine the flow that actually occurs? How can I see it? How can I see the problems? How can I analyze and understand what's going on, right? Because the static diagram was great when we were sitting down asking teams to write code, but right now what we need is to see a different viewpoint. We need to see how it's working at runtime.
And that's where I come in. So thinking about observability, I can talk to you a lot about what observability is and is not, and we'll talk about what modern observability is, which is kind of the best distinction, really. But if you think about how we may have done this in the past, it's not new. We have logs, and we have correlations, and you have a service that will produce some logs that say what it was doing, and then we put a correlation ID on the top of it, maybe an operation ID or something that's bespoke to Azure Service Bus or RabbitMQ. And then on the other side, the logs will be produced by the consuming service, and then we've got 2 logs, and then we throw them into a centralized logging platform. And then this happens, because how many people in the room have checked the time servers on all of their different microservices in the last, let's just say, year? Yeah, I thought so. You're very good, you. But most people don't. And what happens is, even in a synchronous kind of environment, you will get this idea that, well, I've got loads of logs going, and then I've got another log coming in from a different service. Did that happen at the same time as that service, or did it not? If you only got 2 services and they're running in the running series, not a problem. But what happens when you've got 4 different services all consuming that same event, that same command, that same message? Well, all of a sudden now we've got a mess. We don't know which things ran in parallel. And if all those 4 services then call into other services and you've got this cascade of logs in this platform, you don't really see what's happening. Now, the answer, as I'm sure a lot of you have already surmised, is tracing. And we do that to create things like spans that will span over multiple activities or individual activities, and will allow us to be able to see how these interact together. We have lots and lots of tools within the open telemetry space, within the telemetry space in general, from events to spans. Now, ultimately, it's up to you. And this is where we come into how you design systems, how you debug or design your debug experience, because we can just sort of, let's just create a span where we had logs before. Let's just create some span events where we had some logs before. But we also could say, well, let's just create some more spans. And these are just tools that you've got.
So, Martin, that's great, right? You're giving me some spans, but I notice on that diagram you are still firmly within my orchestration, right? So you haven't really solved my problem, because I've got multiple orchestrations and they've all got telemetry in them, but I still can't see my choreography.
And that is where a trace waterfall comes in. It's one view of telemetry data. We'll talk about different ways that we can use this, but a trace waterfall will allow us to be able to see the causality of each of these things. We can see that, well, one action happened before another, but we can also see what caused another action to happen. This message that was produced by this activity caused this service to do this activity. And we can build those and model those and be able to see what would be a full trace diagram like that. We'd be able to see that in a view that allows us to be able to know, well, no, this is what actually happened. So that's what you thought should happen. That's what actually happened.
So this is essentially where I'm getting my choreography at runtime. I'm now able to see that complex choreography. And as Martin pointed out earlier, it's the real choreography, not the one that we designed. It's the one that's actually running at runtime.
Yeah. Now, we do this through something called context propagation. Now, context propagation is something that came out of the W3C. It is not an open telemetry thing, which is what a lot of people think. It's not a Microsoft thing, which is what a lot of other people think. Context propagation came out as a W3C standard many, many years ago. And what it allows us to be able to do is kind of advanced correlation. Now, I would imagine that most people have used a correlation ID in their time. They've added a header that says, oh, this is the unique ID of my request, and then in a downstream system, you've pulled it out and then added it to all your logs or added it to all your console output and been able to see it. Now, W3C trace context takes that to another level. And what it does is it uses metadata from the requests. Now, it might be headers from a HTTP. It might be cloud events and using the metadata out of cloud events. It could be just the application properties on Azure Service Bus. But it's metadata that goes with your message. And it includes some vital information that allows us to be able to see not just the correlation, but also what came before. That's what gives us that view to be able to say, this thing caused that thing. And that's what we have on there, which is our parent span ID. It has a ton of other information that makes it useful as well. we can use sampling information, which allows us to be able to sample our traces in an effective way to manage cost. It also allows us to be able to do vendor-specific stuff using something called trace state and take things like sample rate. So we're not just saying, drop all this data. We're saying, no, we kept 1% of it for this particular criteria.
What happens if you have too much data, Martin?
I don't know, you can't afford to eat.
Yeah. Datadog bills or whatever, or Honeycomb bills can get expensive. You're probably cheaper, aren't you? If effectively...
I didn't say it. I'm just saying. I'm not doing the selling.
If you don't sample.
But yeah, sampling is a mechanism that we use. But ultimately, in messaging, things become a little bit more interesting. In a HTTP context, it's really easy. One request goes out, one request comes in. You can take that message and you can throw it on the top. You can throw the headers on the top, take them out on the other end, job done. When it comes to messaging, things get a little bit more interesting. And this is where we get into this, you've got to curate your experience. Because if you're saying, I've got 1,000 orders and I need to send some emails, what you generally wouldn't do is do 1,000 calls over to SendGrid. What you would do is you would say, here is all of my metadata for the 1,000 things. Here's the email addresses. Here's the template. Go send me 1,000 emails, please. But what trace ID do I use for the action that makes it over to SendGrid? Now, if you're in the AWS and SQS world, what they believe is you just use the first one, whatever the first messages you pick up. They don't anymore because I told them that was wrong and we removed it from their instrumentation, so they put the last one. But ultimately, it's a decision that you've got to make. What you've got to do is you've got to decide what is important for my debug experience. Is it important that I have one span that tells me, one trace, that tells me about all these 1,000 entries that are in there and add some metadata, maybe some way of linking back to the original messages. But you've got to understand it. You've got to do that stuff. And that's why messaging is a little bit more interesting. That's why there's a reason to have a talk like this, because it's not as easy as just install agent, I have 100% observability. No, that is not what you should be doing. So we'll show you some examples of how we can curate that stuff and how we can use the context propagation in our favor to be able to be a little bit more proactive and build a debuggable and observable event-driven system.
And you can even see it in an example as simple as ours. We'll show you later when we run a demo. You can even see the difference that it makes to think about this carefully, even in a demo app. So it's a real concern.
Yeah. Okay, so one thing I want to talk a little bit about is naming. Because I don't know about you, but I've been in rooms where we've spent a good 6 days sat there debating the name of a class. Is it the transaction service? Is it the transaction adapter? Is it just the transaction? That's all it is. Oh, no, it's not a transaction. It's an authorization. No. Naming is hard. And if you think about what we do in the telemetry world, we're adding attributes, we're giving everything. Everything is naming. And it is one of the 2 hardest problems in computer science, along with cache invalidation and off-by-1 errors. Now, in OpenTelemetry, we've come up with something called the semantic conventions. Now, the semantic conventions are a team of highly interesting people who sit in a room and discuss naming all day, every day. They do it so we don't have to. I have utmost respect to these people who sit in meetings on Zoom for hours on end discussing naming. And they've come up with a load of names, some canonical names for certain things. In the messaging world, you've got a couple of them up there, and they've got loads in the HTTP world. Things that are common to the industry will generally have names. Things that are for a pizza shop probably don't. But messaging, HTTP, IoT stuff, all of those things already exist as naming, and you can use them.
And it talks about things like, when you should call your thing create, when you should call it publish, depending upon whether you're, batching work, etc. So the other thing actually I found when we just stuck it into Brighter it also is reasonably good to validate your thinking, because if you can't apply the semantic convention successfully, then maybe you want to wonder whether that's because you're not thinking about your messaging right.
Yeah. Okay, so up to this point, what we've basically got is this idea that we've been able to take our distributed system, we've added a few spans in there, and we've now got maybe a nice big trace that shows us a little bit about the system. But how does that relate to modern observability? Now, that comes down to definitions. Now, if you think about what observability is, now, you can look at the modern definitions, you can go to all of the observability vendors and look at what they say observability is. But ultimately, if you go way back, where the term was actually when we applied it to computer science, where it came from, it comes from the 1960s, and it comes from this idea of how well do we understand the inner system state of a system, just from the public data that it gives us. That's what observability is. If you apply that to something a little bit even more modern, when we started to say, well, everybody started talking about those 3 pillar things, what we actually mean is observability really is a property of these complex systems. In the same way as we think about a system being reliable, we think about a system being testable, we should also be thinking about, is a system observable? That's really where it comes down to. Can we understand what's happening to the inner system state? Now, that could be at different levels. It could be what we're talking about, which is that high-level idea of a pizza shop and how it cooks pizzas and delivers pizzas. It could be as low level as a courier and how they interact. But how well do we understand how that system works? There are no 3 pillars. Observability is not about the data. It's about what we can make the data do for us. It's about what we can use for Ian's use case. How can we use that data to understand choreography? How can we use that data to understand what's happening in a production environment? That's at the core of what observability is.
So remember, when we think about that choreography, what we're modeling is a business process. So what we don't want to just focus our observability on is the technical details of the interaction between the various parts of the system. What we want to be able to observe is the business process at runtime.
Okay. So if you've got this far and you're probably at this point going, yeah, I know all that. I've done all that. It's great. We then get on to the problems. Because in these large distributed systems, we end up with what we've termed gigatraces. Because in these large distributed systems, you look at, say, Monzo, where they published an article, it must have been about 5 years ago, 6 years ago now, where they proudly said they have 1,500 microservices, and the entire development world went, no, don't do that. Apparently now they're up to 3,200 microservices, so nobody told them. But ultimately, if you think about how we think about tracing, we end up with traces like this, which mean practically nothing. Now, I shared this particular trace from our demo in our internal environment, and one of our people came back with that. But ultimately, it doesn't help us. That trace up there doesn't help us. Even if we do add cartoon characters on it, it's not going to help us. And that's where we come into really thinking about how we curate our observability. And it comes into the first thing we're going to talk about, which is span links. Now, span links allow us to be able to take one trace, break it into multiple traces, but still have a casual relationship between those 2 traces. In the example I used earlier about the emails, maybe you've got 1,000 spans because it sent 1,000 emails, and we've only got one trace in this email system that relates to 1,000 inbound messages that came in. What we've actually got is 1,000 links that exist on that one trace that say, here's the link back to the original traces that generated all of these emails. So I'm going to see if I can run a bit of a demo. We have done all of the requisite sacrifices to the demo gods, yes?
We tried, though we are running the end service bus emulator, which requires extra special sacrifices.
Yes. Yes, we sacrifice elder, I think, is the...
Yeah. So I think one of the critical things that, as Martin's just sort of warming it up, that I really sort of picked up from Martin when we looked at this is this fact that we're trying to take observability beyond the idea of the infrastructure connections have to work, and even beyond the idea of I'm just trying to debug the problem that Ian created when he couldn't get his demo working. But we're actually trying to essentially be able to understand the choreography as a business process, as what's happening within our business. And that's why it requires a bit more thought than just saying, oh, yeah, I sent a message, I received a message.
Okay, so we are using .NET Aspire for this. We did have a little bit of a dig at .NET Aspire earlier. I want to clarify a little bit. The first time we did this demo, it was on an early version of Aspire. And the PM for Aspire was sat in the front row, and we gave her a lot of stick. And they fixed a lot of it. So this demo is pretty slick now. Aspire is very much getting there from a developer experience perspective. So yes, it's not as bad as it was. Okay, so we have a front-end API that is our orders API. And I'm going to submit an order for John Doe. And what we're going to get, hopefully, in theory, maybe. There we go. So we've got a trace that's coming through. One of the things about Aspire is the telemetry that is coming through is going to update, hopefully, I think, maybe. Yes, there we go. So one of the things about Aspire is we get real-time view as each one of these spans come in. Now, what you're going to understand is spans come in reverse order. Because a span gets sent to a backend when the span finishes, not when it starts. It comes in when it finishes. Now, what you're seeing here is every 15 seconds, the courier is going, I haven't delivered it yet. I haven't delivered it yet. Wouldn't it be great if delivery drivers actually did that? They were just sort of ringing you and just, I'm not there yet. I'll be there in a minute. Not there yet. I'm here now. Be great. But one of the things that we're seeing is at the start, it was quite easy to see how the pizza was ordered and then it was cooked. But as we've started to get more of these couriers going, I'm not here yet, I'm not there yet, I'm not there yet, the really interesting part is that big. It's tiny. Now, if I think about how I might debug a system like this, the flow of a courier and how a courier is delivering the pizza is a different thing to once the pizza's gone, when the pizza shop has gone out of my hands, we've now got a different activity, a very distinct system that is now running. Now, to make that part of this one big trace doesn't really add value to me. But it is valuable to somebody, and it is valuable to see those two things in context at some times. So what we can do, if I remember where this is in the code base, I think it's here.
Yeah, so we want to see the connection between both these ideas. The idea of the courier sending a status update saying, I'm on my way, and the process of effectively the pizza shop cooking the pizza in response to the order. They're connected, but we want to view them in a way that lets us highlight each one.
Okay, so there's two methods that you can see on screen here. As I say, most of these are in C#. You can do this in all of the 11 languages of OpenTelemetry, from Python to, God forbid, Elixir. But you can run it in all of the OpenTelemetry languages. And what we're doing is we're using something called propagators. I talked a little bit about those context propagation. Now, the first one, which is start new span from request, is going to take the headers from the metadata from this request. And it's just going to start a new span and say, my parent was the one that was on the metadata. That's trace parentage. So we've got a parent and child relationship between those two spans. Whereas the one on the bottom, what this is going to do is it's going to add links, which is this. Let me zoom in a little bit so you can see that a little bit better. And we'll close that. So there on line 52, you can see what we're actually doing is we're saying we want to add the original trace, the original span, as a link. And we've set the current span to null, which means that we're going to have a brand new trace. That's because .NET is weird and they won't fix it. So if you want a new trace, you have to do activity.current equals null, which is really annoying, but it is what it is. So now I have changed this here to use the new root span method. And now we will need to, oh, no, we don't want to do that. No, we don't want to do that. We want to do that. Okay. So let's run that. And wait for Aspire to bring up the 14,000 dependencies. This is not how you build software. Build it small, modular, not monolith. If your Aspire codebase has 14,000 methods in it for 15 services, no, don't do it. Okay, so that should
So what we're looking to see here is that we can get a better trace on the dashboard such that we can more easily understand what is going on. So right, observability needs to be easy to see, and we need to better observe what's happening.
Okay.
So what mine's done is to try and give us a clearer view of how that works.
So run that request again. That should come through, and now we've got a nice clean trace, which is just about the scope of our pizza shop and what the pizza shop is doing to cook that pizza. It was very quick cooking that pizza. What was it, 1.5 seconds? If only we could cook pizzas that fast in the real world, that would be amazing. But that isn't going to change now. Now that request is done. That's really interesting to me to be able to see how the pizza shop, the shop front, interacts with the pizza shop and how the pizza shop cooks the pizza, tells the storefront that everything is done.
And in the real world, we get genuinely useful data here, like information about cooking time is used to calculate ETAs, etc. So being able to surface that data is really important.
And then what we've got is our couriers. And the courier being each one of these spans that come through. That same one that we had that was being tacked onto the thing at the bottom now has a much smaller scope. And it's only showing us how the courier is delivering it. Now, if you think about who might debug these two systems, they're highly likely to be two completely different developers, two completely different teams that are developing these two processes. But what's really important is that from here I can go, well, something went wrong with my courier. Maybe what I want to do is go and view the original trace. And then I can get back. So I have a casual link between the two, but they're very distinct, different activities. But this is something that no automated agent, auto-instrumentation, zero-code thing is just going to go, right, install an agent. I know that couriers are different to pizzas. The pizza shop is definitely different. They don't know. It's up to you to understand your context. It's one of the reasons why I firmly believe that humans will only ever be augmented by AI, because AIs don't eat pizzas. Okay. That's one way that we can start to take our tracing or take our observability to a little bit of the next level. Cool. What was next? Custom instrumentation. This is the bit I love. So custom instrumentation is how we distinguish our system from every other system that your providers of observability might be using. Because your system is a unique snowflake. Because if it wasn't, you'd have bought an off-the-shelf product because it's way cheaper. Because nobody here likes writing the same thing that already exists on the internet, right? No? Good. So custom instrumentation is how we apply our own context, our own business context, to our traces. And that's pretty much simple a lot of the time. You can say that span links is custom instrumentation. I kind of distinguish between the two. Custom instrumentation to me, or manual instrumentation, or there's loads of different terms that you might use, is taking things like, in this scenario, the size of the pizza and the toppings, and adding that in to my observability, my spans. Maybe I'm using log events to do this, but I'm using this stuff. Now, I'm assuming that most people have done logging. And as part of that logging, they've used maybe one or two different namings for, say, production. So the environment, is it pre-prod? Is it staging? Is it UAT? And about 15 different people in your organization will have 22 different opinions on what exactly that naming should be.
And there are also typically different conventions, so underscores or dots or hyphens, lowercase only or mixed case. So there's a lot of can go wrong when you're trying to figure out, are we talking the same language?
And that's fine when we're only looking at one action. That's fine when we say this particular span or this particular log entry is the only one we care about. When we start to think about these things in aggregate, naming becomes quite important. Now, OpenTelemetry have produced a tool called Weaver. Now, Weaver is a really, really interesting tool because, A, you get to write YAML, and everybody loves writing YAML, yeah? But what's better is it marries up arguing about naming with arguing about whether YAML is a programming language, which is an amazing meeting to be in sometimes. But ultimately, what Weaver allows us to do is it provides us with a language, pardon the pun, for being able to define our naming conventions at either an organization level, at a repo level, but allows us to then use that to generate documentation. Because when you've come up with naming conventions, everybody diligently writes documentation about these naming conventions and puts them in a location where every person in the organization can then find them and use them. Don't they? Yeah? Yeah? Everybody nodded their head, so anybody watching this on the video, you're the exception. No, nobody was nodding their head. But Weaver allows you to be able to generate markdown files that tell you that these are the names you should use. These are when you should use these names, in what context. When we say request.category ID, it's different to pizza.category ID. So we don't use just category ID.
And that's going to kind of mean when someone's using a tool to search for given traces or spans, they're going to be able to do that now because they can go and look in that library of information to figure out what should I be searching for to find more information about that choreography.
100%. And what makes this even better, though, is we can also use that same YAML file that we've defined all of our naming. We can use that to generate markdown docs that everybody can use, but we can also use it to generate code. You can generate code in every one of the languages that you use to make sure the JavaScript developers are using the same naming convention as the C# developers. So we can actually remove all of those horrible, horrible static strings all over our code base. Because static strings are evil. Nobody writes them the same. Quite literally, I had a problem when I was doing this demo. This was in a YAML file, because static strings in YAML file are definitely a thing. Where one of the things that we have to add, I think it's on here, it might be on another one, where you have to put requirement level. And I put, instead of opt-in, I put opt-ID, but I've been looking at it for that long, I didn't see the D. And I passed that on to somebody and said, why doesn't this work? And they went, you're an idiot. But ultimately, static strings are like that. You will accidentally add an N rather than a D, and you'll have been looking at that code for 14 hours straight, without sleep, and you won't see the error. But the other thing is, because we have IDEs, because we have go-to-definition, find references, we can actually find these things in one place and then be able to go through all of our software to find them. So, just as an example, we have some stuff in here, and this is the last demo we've got before we talk a little bit about.
You can go and look at this code if you want to go and see what we've done, and you can should better get it running. That is one of the beauties of having something like Aspire, is you should better just get it running quite easily and see all the traces from Aspire yourself in the dashboard and be able to figure out quite how this all fits together.
Now, this is another thing where I really like AI, augmented code. So this is using, I think it might be using Copilot, it might be using Augment Code, it'll be using one of them. But ultimately, it can get you a lot of the way there. But if you look at this, what it's actually done, you see this naming convention here, if I zoom in a little bit. It's used the uppercase S, when really what we should be doing is that. That's because it's gone through the code base and seen that I've actually used 2 different conventions over my code base, and it's just chosen one. This allows me to be able to go, no, that isn't the convention that we're going to use. We're going to use those 2 for toppings. And for some reason, that doesn't like it. Indentation, because YAML. YAML, yay!
Live coding YAML is never a good idea. Well, coding in YAML is never a good idea.
I was going to say this.
Just wait, you know, Aspire's goal was to prevent you coding in YAML, so you just need David to fix Weaver.
Yeah, I'm not letting him anywhere near it. So we can use that. One of the cool things as well, you can run this entirely through Docker, so you don't have to install any tools. As long as you've got Docker. In here, you've got some command lines it's going to pull down. And it all uses these things called Ginger templates. So you can use these. You can actually use them from the repos. You don't have to write them yourself. But we're going to run that, and that should add some stuff into, there we go, our pizza attributes. And we've got a load of pizza attributes now. And we can go through and say, in our kitchen, we're going to cook the pizza. We've got our pizza size with the wrong name there. Let's add our pizza attributes.
So if we'd used the wrong names, it would be very difficult for us to do any kind of analytics, right? We wouldn't be able to find out, you know, how are we able to cook pizzas so fast, or why are couriers so slow.
Okay, and now what we've got is, when we cook a pizza, we can see that there's a bit of a problem. Now, why is this really interesting? And this is the only time I'm going to mention Honeycomb, just because it's the easiest tool to do this in that I found. That's why I work there. But if you imagine that we're looking at, why is it taking us so long to cook pizzas? Pizzas are for some reason taking some time. Now, what I've got there is I've taken that data that we've generated. So we've used that data to generate some trace views, and we've been able to see what's going on in different ones of these traces. Maybe that'll work. So we can see what's going on in these traces. But ultimately, for some reason, our pizzas are taking a long time to cook, but we don't know why. Now, if we take the data that we're using to explain away what Ian needs in order to understand how this system works together, and then say, well, I still don't know, it's still going into the oven like everything else is going into the oven, why is this one different? Well, what we can do is we can take that and we can use what we call a heat map or a bubble up on here, or anomaly detection. And we can say, right, well, let's look at our cook pizza span, our cook pizza activity. Let's graph that data and say, how long does it take? But then say, oh, look, we've got a pretty interesting distribution here. We've got a load of these ones at the top. If we actually add in the size of the pizza, if we add in the order ID, if we add in the location or the distance it's going to take somebody to deliver a pizza, all of this data, we can actually analyze at scale this data and say, well, actually, look, all the ones that are taking a long time are the extra large pizzas. That tracks, because I like a 15-inch pizza from Costco. That's But ultimately, this is about modern observability. This is about taking that data, curating it, making it better, using it for more than one purpose. We've got choreography. We've got the idea of what is actually happening in production. We've got what we originally liked, what we originally decided it was going to look like. But that's really where we can go with thinking about more modern observability. So the solution we've got that you can go and have a look at, it's got HTTP calls in there. It's got some service bus calls in there. We're actually using .NET channels in a few places as well, which mean they've got their own intricacies with how tracing works and how you've got to do that yourself. There's some Kafka in there and some entity framework as well. So you've got kind of a bit of a mix of all of the different things. Hopefully that will give you some kind of examples that you can use. So yeah, there's a bit of auto-instrumentation. We are using the experimental service bus tracing library that you can use and enable. I've also implemented the OpenTelemetry collector in there, so you can then filter out some of your data. All of this is around you curating that data. This idea that we don't just install an agent, send data to a backend, pay them our firstborn, and hopefully they'll give us some insights.
So we set out on this journey with a kind of problem. And the problem is that when we get into distributed systems, and particularly when we get into messaging, we lose a lot of the observability of our system. We can't see a stack trace. We can't debug. We don't tend to know what's going on inside. And so our first port of call was thinking about that, right? And we see this problem a lot. When I introduce new engineers to things like event-driven architecture as a form of DevSys, you see this panic look on their face, which is kind of like, but now I don't understand everything. Now I only understand the messages that my system sends and receives. I feel cut off from the wider world in which I'm operating. So the first port of call we had here was to say, well, look, we have this kind of choreography diagram that shows the interaction between our systems. How could we get that kind of choreography view to happen at runtime to tell us what's really going on, what systems we really have, what messages we actually have, not what we thought at design time.
What did Martin do on the plane on his way to the conference?
Yeah, what is your friend do to your system when you're not looking? And see that at runtime. And that is what observability gave us. It gave us that ability to understand a distributed system and see that flow of events. To do that, we obviously have to use things like trace parent and trace state in order to basically get that context flowing between the systems. But more than that, what Martin's also shown us is that we can go beyond the simple notion of, I want to understand from an infrastructure perspective that things are connected together, but I also want to get genuine insights about how my business is operating, because that choreography is a business level interaction. So I want to sit at that level as well.
Awesome. Basically, one view isn't enough. Use this data, use it multiple times, use it for more things than just displaying a trace waterfall, but use that trace waterfall effectively. So that's all we've got time for. Thank you so much for coming. Slight bit of housekeeping. Apparently the red cards are broken. So if you were going to use them, don't. Just use the green ones instead. Seriously, if you want the red cards, come talk to us. Tell us what's wrong. Tell us what you want to know. We'll make it better next time. Thank you very much.